And I think we are good to go. All right, Sonja, whenever you're ready.
All right, well, thank you. Thank you all for being here today. As just was mentioned, my name is Sonja Swiger. I'm an entomologist with Texas A and M Agrilife Extension. And most of my work focuses on livestock or medical insects of importance. And today we're going to talk about mosquito control and vector-borne diseases. So just kind of an introduction into the concerns with diseases and how they all affect us, especially in the ways when it comes to vectors. Obviously, after what's happened the last couple of years, it makes it a little easier to explain the transmission and the movement of diseases, but we do want to kind of focus down on it when it occurs with vectors. While we live in the United States, we're lucky in the sense that our vector transmission is much lower than other countries, but we still do have vectors of importance that are found in the US. In a whole, vectors do serve in contributing to 80% of the world's population for risk when it comes to their ability to transmit diseases. And as you can see from this diagram, there are different vectors that are of concern. Now we're kind of focused today on mosquitoes because those are the ones that impact the United States the most in the majority of locations. Ticks are another one that could be discussed at this capacity, but we'll leave that for another talk if you have an interest in it. Other ones to be concerned with are fleas and flies. They can play various roles when it comes to transmission of various diseases. And another one that impacts Texas is kissing bugs when it comes to the transmission of Chagas disease. There's a few others that are shown on here. We don't typically see the transmission from these insects or arthropods, such as lice and mites in the United States, but they still do have their place and can cause some concern. A note listed on this slide here is that over 700,000 deaths are caused by vector-borne diseases annually. And of course, that can fluctuate, but that's one of the more recent numbers. The focal point of mosquitoes has a lot to do with the fact that they are considered the deadliest of all animals. Obviously, mosquitoes themselves are not going to kill you from just biting you. It's what they're going to give to you that's going to cause that bite. Although we do see animal deaths from sheer numbers of mosquitoes, it's rare to see that in humans. And we see a lot of changes coming forward. Again, after the pandemic, whether we're in it, when we're in it and we're surrounding it, we see these changes and what has happened, it makes this a little bit easier to explain. The world is changing and that causes diseases to change. So as we move into areas that were underdeveloped, we can disturb different diseases that are in the soils and we can move those to new locations. So lots of changes that happen and allow for these movements, but it's not the vector that is moving, it's the disease itself, and the vectors are already located in these areas. Now we are seeing some increase in vectors moving further north as we see climate change and the ability for them to survive or adapt to winters that they may not have been exposed to originally. In the sense of vector-borne diseases, this I guess I call it a diagram or chart or picture, however you want to refer to it, but it's developed here to show the impact of these different vector-borne diseases throughout the world. And the darker colored countries are the ones that are more heavily impacted. So a lot of our diseases do originate in Africa when it comes to the vector-borne part of that, and then they move from there. So from Africa to Southeast Asia and then South America, those are our most heavily impacted locations. And again, some of those will move further past those zones. So when looking at the United States in particular in mosquito-borne diseases, there are a few that we would say are endemic, meaning that they are found here all the time. We have the vectors to sustain them and we are sustaining them. Now, do we have them in large numbers? Probably not every year, but they're here and they're going to occur almost every year somewhere. Now, there may be a few years when they don't, but for the most part, if you are in an area where you've seen it before, it's highly possible you're going to see it again the following year. And we also have our imported diseases. So a lot of our imported diseases are carried by Aedes mosquitoes, and I'm going to get into that in just a little bit. And they're listed here more closely to the top. Now, these are still observed in a sense, because we want to watch for people coming to the United States that are carrying these diseases. because they are obviously the vehicle to move them around, and then be concerned if our local mosquito populations will get involved in that transmission cycle. So malaria is listed there, chikungunya, dengue, yellow fever, and Zika. And then the ones that are already considered endemic are Eastern equine encephalitis, lacrosse encephalitis, West Nile virus, St. Louis, and then again, Western equine encephalitis. We're going to talk on a few of those diseases, the ones that are considered the most important for Texas. But before getting into there, we're going to do a little bit on the mosquito biology. As most of us are aware, mosquitoes are aquatic breeders. Water is a necessity for their life development. The only stage that's not going to be in water is the adult stage, so it's considered terrestrial, but it still has to have a water aspect to it, correct, right? So the larva and the egg are associated with the water more than the adult. It takes about 4 to 14 days to go from the egg to the adult stage, and it depends on species. So that number varies based on species. It also varies based on the temperatures outside. In the cooler months, it takes longer to grow than in the summer months. The majority of our insects are going to be active at dusk and dawn, and mosquitoes fall into that same thing. So while some will be active more often outside that time period, that's the most active time period because it's really nice out at that time. The sun's not really hot yet, and it's just a little easier to come in contact with your host if you're looking for one. Our important species are what we consider more associated with humans and more urban based, right? So to be a vector of a disease that impacts humans, it helps to live near those humans. So these mosquitoes are kind of adapted to it, or the situation surrounding the way we live in those areas makes it easier for the mosquitoes to survive. And we do have some mosquitoes that we call considered daytime biters, and then others are nighttime biters. The nighttime biters usually go unnoticed, but West Nile, the disease carrier, is a nighttime biter. So that mosquito likes to fly at night. So that's why a lot of our programs are directed to spray at night. There's other reasons, but that was one of the focal points, is that your main vector was active then, so you spray then. But we do have a lot of mosquitoes that will bite you during the day. So what are some of the species of most concern to Texas? The reason I like to break them down, and I'm really not going to get too speciated, but genera and species, depending on which one we're talking about here, is because they all act a little different. It is kind of thought we can group all mosquitoes together, we can talk about them all together, but we can't. There are 85 species in Texas, and they're all a bit different. They're not all found in one location, thankfully, but they have different roles that they play. And luckily, most are not carrying diseases. So the ones we're going to focus on are the vectors, the ones that carry diseases. Now, there's several outside of this that can be of concern depending on the programs and the areas you live in, because there are so many of them. And when you get close to the Gulf Coast region, we have lots of mosquitoes, what we call salt marsh mosquitoes, that are of concern, but we're not going to talk about them in detail today. So we'll begin with the Culex mosquito, in particular, where you guys are located in the state, and for most everybody in the state, Culex quincunfasciatus is the species of concern. There's another Culex, which is shown in this lower picture. It's a western mosquito, which is found in, as it says, out west. So Lubbock and El Paso are the places we find it collected most often. But for the most part, when it comes to West Nile and the transmission in the state of Texas, it's the Culex quincunfasciatus, which is the mosquito on the top, sometimes referred to as quinks, because that's a really long name to say. The caveat about this mosquito is that it is a bird biting species, which allows for it to be the carrier for West Nile, because West Nile is a bird-borne disease. The birds serve as the reservoir. And it actually would prefer to always bite birds. But when the population gets high, or if it just happens to be time to get a blood meal and it's not in the mood to go find the birds, it'll bite on a human, and it'll bite on a horse, and it may bite on other animals. But the ones of concern are horses and humans, because we can actually contract West Nile and become clinically sick from it. So it's referred to as a pest mosquito. It's said to have a very painful bite and can be pretty persistent when it's in the, when she's really trying to hunt down her blood meal. The other thing about this species is that it's more of a drought species of mosquitoes. We always kind of think of mosquitoes as when it's raining and there's a lot of water out there. That's when our mosquito populations are the highest, but that's not true for all of them. Now, there are some that, yes, that's a very big part of it. If you're a floodwater species, you don't do so well if there's no flooding, there's no standing water. But when you're a Culex mosquito, you actually do better when there's less rain because they have a preference for highly organic water. So basically they evolved over time to realize that there's these concentrated areas of water that have a lot of organic matter, usually pretty gross, and nobody wants to use them. So she's like, hey, this will work for me. I can make my eggs grow there, my larvae grow there. So they do. And then they kind of increase during the driest part of the season. So we are right now heading straight jab into the middle of West Nile season. If you've kept up with that, you slowly watch that the numbers are climbing every week when it comes to what we're finding. So as I said already, the disease of concern with Culex is West Nile, and another one is St. Louis encephalitis, and I'm going to talk about those two here. So West Nile is our biggest concern. It's one of the main reasons why we have mosquito control. We want to keep this number below, or these numbers low, so that we don't have a large number of people becoming ill from it. As I already mentioned, the bird is the reservoir host for West Nile. So you can't get West Nile from anywhere else except for the mosquito, unless you do have, contact with infected blood, but that's, usually something we prevent, but there's no other way to get it. So if you handle the bird with no issues, the bird's not going to give it to you. You're not going to get it from the horse if the horse has it. The mosquito has to go bite the bird, and then that mosquito will go lay her eggs, and then she'll come back for another blood meal, and that's when she will transmit it to somebody else, because blood meal number 2 could probably be a human, and she's infected with the West Nile. They do have to acquire this every year, so it's not something that they keep in their system all year round. It doesn't pass through the larval stage, which is good, but they do, so that will fluctuate our numbers. So that's a good thing in some ways, because it doesn't always stay high. Unfortunately, right now, there is no vaccine for humans. It's just kind of a protect yourself in a sense that you want to help ease any issues you may be dealing with when you contract it. But there is a vaccine for horses, which is highly recommended for use. With this virus, a lot of people will not even really know they're sick. They'll be what we call asymptomatic. They'll have no symptoms whatsoever, and they'll never even know they had it. But the benefit is you do get immunity, even if you didn't know you didn't have it. About 20% of the population who do contract it will feel pretty ill. They'll be okay to probably, work through it at home without any medical intervention, but they will be impacted by it enough. So probably not be able to go to work and take a day or two off. Some take a couple weeks off. It just depends on your immune system. And they do know that the older you get, the more impacting West Nile can be on you. But we also do have young children that can have more adverse effects. And then there is a small percentage of the population that comes down with the neuroinvasive form, which is the most severe form. And it requires hospitalization, medical intervention to ease your issues, because it can lead to swelling in the brain or the spinal column. And it can be pretty rough on the body. So most people who do contract that form are going to seek medical care. And if they don't, a lot of times they won't survive. So that is the fatal form. In Texas, we've had West Nile since 2002. Obviously, I didn't put the numbers up for the whole time. It's been here just the last decade to kind of look at. And it fluctuates quite a bit. In 2012, we had the biggest year on record so far, and let's hope that we can keep it as the biggest record and we don't ever see that again, but we never know what the future will hold for us. And we had 1,800 plus positive West Nile cases, which is quite significant. Most of those were in the DFW area. And we had 89 people that ended up passing from that disease. So that's extremely high. That was a huge outbreak that took a lot of people getting involved to bring that back down. But since then, numbers have stayed lower. One thing I know I've added in this chart, as you notice, it goes across, it's got the years and then it's got the disease. Then the next two lines are is the disease broken out. So if you take line 2 and 3 for that year and add it together, you get line 1, just to kind of explain that. And then the deaths based on what I could find. So the data comes from the Department of State Health Services, and if I can't always find it, I can't provide it. But and then the mosquito positive pools. One thing we do note, if you can find the data, is that before 2012, there weren't a lot of numbers of pools that are being tested. Since then, you'll see high numbers of mosquito pools being tested. This is just the positive tested, not all the numbers. So they test thousands and thousands of mosquitoes every year now. And they have before too, but now they really test even more to keep an eye on this virus as it moves around through an area and through the state. As of this week, I believe this is week 31's data here, we've had 537 positive mosquito pools, and we have 2, maybe 3. I think the third one has come out, but it wasn't yet recorded by the state, 3 positive human cases of West Nile. And you'll also notice there's 3 positive dengue cases as of this year. And the very last column, if you've ever looked at this data, it's available on the State Department of State Health Services website, is that the PVD are those that are blood donors. And we have 9 positive, and those are 9 people who don't know they have West Nile. They had gone in to donate blood, they tested their blood, and they found out that way that they had the titers for West Nile, and they weren't, obviously the blood was not allowed to be used after that point. So the data here seen on this figure is to show where we had cases of West Nile last year in 2020. We had kind of thought 2020 was going to be a really busy year for West Nile, but I think due to the pandemic and everybody kind of staying inside more than they normally do, it kind of kept our numbers low. If you've ever looked at these graphs that are made by the Department of State Health Services, you kind of see repetition. Usually the counties that are highlighted are always the same counties, because that's where our programs are most heavily focused to do this surveillance. What I have done is I've kind of taken what their map and I color coded so it breaks down as to what you're seeing. So we did have 4 positive, I say horses, it could be more than 4 horses, but 4 horse county positives for West Nile in 2020. The mosquito pools are marked in the yellow, the horses are in the green, and then the blue and the oranges represent the disease, the West Nile disease, whether fever or the neuroinvasive form. The other thing to note is that if a county has multiple things, I tried to color those in, just so you can kind of see how it was spread out throughout the state. For this year, we are already kind of seeing those same counties. So if you kind of flip back and forth, a lot of the same counties are already positive. Again, those are the ones that are doing the surveillance for the mosquitoes. And when you do the surveillance, it keeps you prepared in a sense so that you know if there's virus activity, plus it keeps an eye on your mosquito populations. So right now, Dallas County is the only one that's had human cases, but you can see there are other positive mosquito and or chicken situations. And actually Harris County has had quite a few birds. They're the only county that still actually does bird surveillance. So they list that as avian as opposed to sentinel chickens, which is a little bit different. And then another disease of concern in the sense of culex is going to be St. Louisencephalitis. St. Louisencephalitis used to be a much bigger concern before West Nile arrived into the United States. It kind of got knocked out of the way upon the arrival of West Nile. It's very similar. A lot of people don't react to it, but the concern is that if you do, it can be pretty severe. So very similar in the way that this virus functions compared to West Nile. The vector is the same. So you've got those culex species. Again, they get it from birds, but the birds in this case are typically a different bird species than the ones that carry West Nile. In the last couple years, it's been pretty quiet for human cases. So you can see in the charts, we haven't had a whole lot of human cases in the last decade. In 2023, human cases were counted in 16 positive mosquito pools. One thing I've noticed, we are they do the surveillance for this, but there's a slow increase. And I don't know if this is like West Nile where we'll see an increase and then a decrease. We'll have to see how this year pans out. But from the last 3 years into this year, you can see we've slowly started to increase those positives of St. Louisencephalitis mosquitoes. And those are mostly being found right now. El Paso finds them every year. Lubbock found them last year, and so did Nueces County. So we are finding St. Louis encephalitis around in various locations of the state, which is interesting. And then we usually have chickens around Galveston, Harris County that post positive for St. Louis as well. So the next group of mosquitoes to be concerned with are Aedes mosquitoes. So we kind of call them by their name again to kind of separate them out by their functions and the way they play a role in transmission. Aedes aegypti is the first one here. This one is our yellow fever mosquito. And yes, while we don't have yellow fever circulating in the United States anymore in Texas, it's still the common name given to this mosquito because that's basically her claim to fame. She is notorious for transmitting that disease and at high rates when it's present. Her other diseases of concern are dengue, chikungunya, and Zika. So this is a very prolific vector. She does an exceptional job when it comes to transmission. And one of the reasons why is because she's very happy to be around humans. In most locations where she is found, they are highly specialized and evolved to live with humans, around humans, and they understand us and our patterns. So this is a container species, which means that she no longer lays her eggs in natural sites. She lays her eggs in man-made devices. So think buckets, gutters, tires, things of that sort. Anything around your house, a can, a jar that can hold water would be a place that she would want to put her eggs, and she does. Now, these mosquitoes will also lay those eggs in the drought times or the dry conditions, and those eggs can sit there and wait until the water returns. So this mosquito can be year-round in some parts of the world when they don't have winter. So they can be really problematic if you're in those locations because of that aspect. The other aspect that makes her such a good transmitter is that she is one of the few mosquitoes that actually doesn't take a full blood meal on a single person. She would prefer to take a small blood meal from multiple people and move around to increase her chances of not getting smacked while she's getting her blood meal instead of taking a full blood meal from one person. And when you do that, you increase your transmissibility. So she can go, 10 people, 20 people, if they're all before she's completely full. And each time, if she gets the proper connection, so to speak, and starts spitting enough saliva into those persons, she could potentially infect every one of them. Another one is Aedes albopictus, is considered a cousin species to our Aedes aegypti. Aedes aegypti has been in the United States since forever, basically, very, very long time since they basically have founded the New World. And then albopictus has only been here since 1985. So referred to currently as the Asian tiger mosquito, reference to where it came from. It did originate from Asia. This one is not as good of a vector, at least not yet. Can it change? Potentially. But the concerns with Aedes albopictus is more about the fact that it's a much more aggressive daytime biter, much more aggressive biter altogether. It bites lots of animals, and it can survive further north. So one thing about these two species is that aegypti is considered more of a tropical species, and albopictus is more temperate. It can go further north. Now, does that matter when you live in Texas? Maybe not, because we're all pretty much tropical, right? We're all down here in the South. These maps were put together by CDC several years ago when Zika hit, just kind of to get people prepared to think, well, if you're in one of these located, somewhere within these colored regions, whether you're blue or green, you may need to be concerned with Zika. One thing I'd like to point out is that in the next slide I'm going to show you is that we did a study to look for these two species in Texas and kind of note where they have the green parts on albopictus, the one on the right here. The one thing I like to point out is that there's a lot of light green out in West Texas. So we over the last couple of years, participated with the Department of State Health Services to do a surveillance of these two species. And these are our maps that were developed. The one on the left was what had been recorded prior to us doing this intense surveillance. This was coming in from various mosquito groups over the years. And then we added, by getting, in my case, I got a bunch of my county extension agents involved and helped add these different areas. The hashed or lined counties, which are the black and white, or they could be green and white or green and black if they have the both species there. Those are the Egypti, or the albopictus, and the green ones are the Egypti. So you can see that by doing surveillance, we have noted that these two mosquito species are found quite heavily throughout the state. And you can see that there's a lot of West Texas that has albopictus, despite the CDC's predicted map that I showed you just in the last slide. So it's pretty obvious or pretty easy to say that we probably have both species throughout the state. There are some areas we haven't found one or the other. So like far west or in the deep, I guess this is the Big Bend area, west part of Texas. We haven't found albopictus there, probably because there's not a lot of trees and that's kind of where it prefers to grow. And then in the deep east part of Texas, the southeast, we haven't found a lot of Egypti and it's more heavily treed. So that could be a factor, or it could be just surveillance techniques. So the diseases of concern with Aedes are plenty. And most of them are pretty damaging, so they can be cause for concern. I'm only going to talk about dengue in detail, but yellow fever is another one to be really concerned with. Again, we do have a vaccine and it has been eradicated from the United States, but we do watch that one closely. Another one is chikungunya and Zika, which they kind of showed up on the map and kind of disappeared just a bit. They really haven't done much since we first had their kind of a surgence of them in 2015 and 2016. And then a few others, Louisencephalitis, which is actually carried by different Aedes, not the Egypti. And that one's found in more, what's the place? It's not the south, it's the more northern part of the southeast of the United States. So like Tennessee and Kentucky and areas like that. So I guess it's sort of Midwest-ish county states. We don't really see it here. And then Rift Valley fever, which is not yet in the US, but it's a really important disease that we watch very closely because it's carried by many different species and we expect Aedes aegypti could carry it. And it can impact cattle and humans alike, and it actually can be fatal. So dengue virus is the biggest concern at this time when it comes to Aedes aegypti because of the fact, again, that we have the vaccine for yellow fever. It's found in more than 100 countries worldwide, which are noted in this picture here with the blue. The darker blue indicates the more likelihood of dealing with that disease. 40% of the world's population, which are obviously found in these areas, are at risk, and that is roughly about 3 billion people. So it is a leading cause of illness and death in those areas. And of course, if you live outside those areas, we kind of forget about it because it doesn't impact us, but we're kind of on that cusp where we're going to see people with it. And maybe we could have it as well, especially in the southern part of the state of Texas. Up to 400 million people get infected each year. And out of that, 22,000 die from severe dengue and 100 million get sick. If you're not familiar with dengue, it is a very unique virus. And I will straight up tell you, I'm not a virologist, so I do apologize ahead of time. I can't explain it as well if one of them was here, but it has 4 serotypes. And if you get one serotype, say if you got the dengue 1, and then you got dengue 1 again, a second time, you do build immunity to dengue 1. So getting it once, you may get a mild illness to it, and then you got dengue 1 again, and you probably won't have much impact from it. But the problem with it is that if you get dengue 1 and then you get dengue 2 or 3 or 4, your symptoms are worse with that second serotype you've contracted, as opposed to if you contracted 2, 3, or 4 first, and vice versa. So it's a very complex virus, and that if you continually get the same serotype, it shouldn't get worse on you. Your immune system should sustain the ability to protect you. But if you keep getting different forms of it, it actually compounds against itself, and it leads to what they call either dengue hemorrhagic or breakbone fever. And that basically means a lot of what it says. So hemorrhagic is bleeding of the capillaries and can be very damaging and very painful, and a lot of times fatal. So we do record cases of dengue. Now from the Department of State Health Services, these are all imported cases. They didn't have it separated if any of those were actually contracted on US soil. That gets listed separately a lot of times because that meant our mosquitoes were carrying it. So I did put dengue, chicken, Zika all here together. And again, the diseases are on top and the years are down the side. In the most recent years, we've had dengue. Last year, we had 62 confirmed cases. And again, that's, those that came and were tested by somebody. In 2019, there were 74. So we do have quite a few cases of dengue every year. These are all going to be travel associated. And most of the time they do fall in South Texas because there is dengue in Mexico. And the last two mosquitoes that I wanted to kind of throw in here to just talk about are the carriers of what we call Eastern equine encephalitis. In Texas, most of the time we don't deal with equine encephalitis, Eastern equine encephalitis, which I'll refer to as triple E because it's a big, long, lot of words there to say fast every time. But there's two mosquitoes in particular. One is the Cochlea melanura, and the other one is the Cochlea, which we'll talk about in the next slide. The reason these two mosquitoes are mentioned here is because of their ability to be the carriers of this disease. The interesting thing about this Tripoli is that it takes actually two vectors at least to become an issue. This mosquito, the Cochlea, doesn't bite on humans. It has no interest to bite on us, which is kind of nice because it's a big mosquito. But it is the one that's biting on the birds and picking up the Tripoli and causing transmission of Tripoli amongst the birds in its locations. And the map up there kind of shows a circled area where we can expect to see this mosquito. It is a swamp species, as it says here. So it has kind of a very unique and distinct breeding habitat. The other mosquito here, Cochlea, is also found in these same locations. Now it can kind of expand a little bit beyond the swamps and be more marshish, to ponds, to lakes with a lot of aquatic vegetation. That's basically a swamp, right? And they have a little bit different life cycle. They only have one generation per year, but they love to bite humans. They're very vicious. They go right after any human that comes near them. The benefit is that you have to kind of go to them. They don't fly very far. They stay close to home, but they also bite on the birds. So what happens in the cycle of Tripoli is that the Cochlea gets it, which is this top mosquito represented in this diagram, mosquito vector number one, so to speak. Cochlea gets it, bites on this bird, and then these birds and this mosquito keep transmitting it. Well, then Cochlea comes in and hanging out in the swamp, and it needs a blood meal and says, hey, that bird looks good. So it bites on the birds and it becomes infected. So now you've got two mosquitoes that are infected with Tripoli. They both got it from the birds. No problem for Cochlea. She wants nothing to do with humans. But the other one, Cochlea, is like, hey, humans work for me. And then it goes and bites on the humans. And I don't know if I mentioned this before, and I don't know if it's said on the other slides, but the dead end host is the human. That's dead end for the virus. So just a heads up on that. It's not certain death, obviously, to contract any of these viruses. It can be of concern for some, but the virus itself can't be replicated in humans, and we can't carry it forward through a vector, is what that means. But the big concern with Tripoli, and the reason I have it in this presentation and most of my presentations when I talk about vector-borne diseases, is because of its impact on humans. If you contract Tripoli, 90% of those that get it will be symptomatic. You will be sick. You'll be dealing with a fever. You'll be dealing with virus symptoms, right? Out of that 90% that are now infected and showing symptoms, 33% will die from it. It's a very high infectious rate to fatality. So that's, and actually 33% is the approximate. The last couple of years, the data shows it's closer to 40 to 45%. Now there is still some people who will be Asymptomatic, never, that 10% will never even know they had it. But if you're in that 90 that is ill, it can be extremely concerning, especially if you fall in the 33% amongst that 90 that can die from it. So it's a very severe disease. It actually in 2019 was the worst year on record in decades. And I think almost since CDC started recording it. It was pretty intense that year. As you can see, Texas is not really a place for Triple E, but because of its severity, it's worth mentioning because East Texas and Louisiana are right next to each other. And if Louisiana were to come out with an outbreak, East Texas could easily suffer an outbreak just at the same time. So I do like to mention Tripoli. The last time we had it, again, 38 cases confirmed in 2019. And I believe it was like 16 of those people died. It was really high death rate. It was closer to like 45%, most of which were in Rhode Island, Massachusetts, and Michigan, I think were the hardest hit states. I know it was Michigan and Massachusetts, and then there was some in Connecticut. So it's a very kind of odd location for this one, but it's really, really a real big deal. So once they start to get one case of Triple E confirmed in humans, the CDC jumps all over it to shut that down, because if it's left to fester, it becomes really, really bad. So in the last part of this presentation, I'm going to go through control measures, right? So we got diseases, we know they're concerning. The benefit is that most of the time the mosquitoes are not infected unless we're dealing with West Nile. And that's of course a big deal. But the most important thing is we want to kind of be integrated on our pest management approach. I do like to say that in vector control, mosquito control, it's not necessarily a full-on pyramid because our system is a little different. If you're dealing with a disease outbreak, chemicals become super, super important because that's the only thing that stops the adult vector stage of mosquitoes, no matter what. It's the only thing that's going to make an impact on them. It's the only thing that's going to control them and bring them down to levels that will stop a transmission of disease. But in most situations, we do want to try and follow our pyramid, which means that we do preventative measures first. We try to find things that will change the situation to not promote vectors or mosquito growing. And then we kind of try to find the more safer routes to go for control measures. In order to do that best in vector control, you need to have surveillance, source reduction, different means of controlling the different stages of the mosquitoes, and then public education, repellents, and resistant management. And I don't know if I have too much of those last three in this actual presentation, but if those are something you're interested in, I'd always be glad to answer more questions. So one of the main things we really try to assist people with and enforce is surveillance, especially if it's a full-blown program that's doing vector control, mosquito control. They should have a surveillance program, because without a surveillance program, you don't know what you're actually doing. There's no way to watch the effects of what you're doing. Even if you're just spraying chemicals, well, how do you know your chemical is effective if you're not doing surveillance of the mosquitoes? Now, surveillance can be very simple to very high tech. There's many ways to do it. They're using drones for it now, but it doesn't have to be that way. One of the easiest ways are looking for eggs with ova cups. It's literally just a black cup. You set it outside for a few days, you see if anybody lays eggs on it, and boom, you know you have mosquitoes. Now it is just for Aedes mosquitoes, but it still tells you have mosquitoes. You can use a dipper. The gentleman and the woman in the top picture are actually out dipping for mosquito larvae and pupa. They're going to a water site, they're using this little cup, and they're looking to see what's in it. The dipper helps because the larvae will swim away if you disturb them. Plus, then you don't have to get down in the water yourself, so you can kind of bring it up to yourself. And there's a standard size to those dip cups, so you can kind of do calculations based on the amount of numbers you're finding in 5 dips. Next, we would go to adult surveillance, which can be very helpful, but the problem with mosquito adult traps is they're a trap, right? You are trying to entice them to come to this trap. Just because your traps are not getting high numbers does not mean there's no mosquitoes. And if you're not getting anything, it may not mean there's no mosquitoes. You just may not have your trap in the right location. So they can take some work and finessing to understand how to use them. And then another tool for surveillance is for diseases. And if you do have an interest to determine if there's a disease present, there are certain traps that need to be used for that. One in particular, West Nile in St. Louis, the trap shown on the bottom is actually a trap that's designated for Culex mosquitoes, and it's referred to as a gravid trap. When you do the larval surveillance, it gives you information as to whether or not that site is a problem. It also lets you know that, hey, if I do some treatment right now and kill my larva, I'll have less adults later. Now, we'll never kill all the larvae, but we'll try to do what we can. So you can stop them before they can fly. The larval stage can't fly, it can't leave the water source, and it can't transmit diseases. So we want to hit them and stop them there if we can. For the adult surveillance, there are different trap options. So for 80s, we usually recommend the trap pictured here on the left, which is the BG2 sentinel traps. These ones are easier to use than the BG1s. They're easier to set up. They're much easier to carry. They're designed to attract 80s mosquitoes. You won't catch a lot of mosquitoes in there. It's not really good for looking for diseases because these are designed to run off of an attractant for a mosquito wanting to look for a blood meal. And typically that mosquito has not taken a previous blood meal, so she won't have any disease to share with you, but you at least can get confirmation that they're present. And like I said, the over trap, which is shown here is the little black cup, it just says, hey, we got 80s because they laid eggs on our strip. Nothing else can be a gain from that, but it at least will tell you they're there. For Culex surveillance, we do use gravid traps. These are just two different types of gravid traps. The term gravid means full of eggs. So that means that that mosquito has already taken her blood meal, most likely a bird. It had to be a bird at some point, whether it's blood meal 2 or 3, she may have a different blood source in there at that time. But after she takes that blood meal, she digests it, and then she produces her eggs. And then she's going to go find a place to lay them. And since these mosquitoes like highly organic water, we have to make what we call stink water, and we put them in these traps. So it's just a tub, kind of like a busboy tub. And then you put the trapping compartment on the top, and when she comes in to lay her eggs, she gets sucked up through a fan. So this will then tell you yes or no, you have West Nile. So those are sent off for testing. 2 other traps, if you're not sure what you're looking for, these are light traps, the 2 different types, the larger one and the more compact and portable one, the CDC light trap. And these can be used for all types of mosquitoes, but again, they're going to attract non-blood fed mosquitoes. Next is source reduction. So when you're looking for the larva, what you're going to find is sources that they live in, right? So it's very easy to say, oh, now let's get rid of all the breeding sites. It's a lot harder sometimes to implicate that, but you want to try and do what you can. I really like this diagram. I'm not sure exactly who put this one together, but it gives you kind of a concept of thinking about common places and then outside thinking of other places that mosquitoes will grow. And in this diagram, it represents many different species. So anything close to the house and containers, wheelbarrows, kids' toys, bird baths, gutters, those are going to be 80s, but you'll also get Culex in the gutters. If the bird bath is really gross, the Culex will go in there. I have a pool for my ducks. The Culex like the pool for the ducks because the ducks are kind of dirty. You got pools with tarps or even pools that are open and not tended to. You got ponds, you got ditches, and you also got the underground sewer system, which is a big spot for Culex mosquitoes. So this just kind of makes you think a little bit outside the box as to where obviously water's holding, but sometimes it's not a big thing. It could be a leaky faucet. And if it leaks every day, there's always water there. And we found mosquitoes in little puddles in the grass, which would not look like they would hold mosquitoes, but it was just enough because there was nothing else, and they'll make use of it. For biological control options, again, it's if it works for you. I mean, nature has its way of controlling insects. They control each other. One of the best options is using fish. The gambusia are a bit more inclined to eat mosquito larvae, so those are usually recommended. Turtles can help. Other predatory insects. So this one is a dragonfly nymph. And then even copepods were looked at by the New Orleans Mosquito Control with some promise, but not a lot, unfortunately. But one of the things I like to point out is while biologicals are great, they're not always effective. If your goal is to control Aedes aegypti, you can forget it, because Aedes aegypti is living in buckets, living in gutters, living in bird baths. It's not in a place that you're going to have predators, and neither is Culex. So Culex mosquitoes grow underground or in really disgusting water that nothing else can survive in. That's why it's there. So that's not places that biologicals are effective. But if you have large bodies of water, you can utilize them well. We always recommend them for many different sizes of lakes and ponds and things of that sort. So we're kind of left with pesticides. And again, there's nothing wrong with using them. It's using them appropriately. All the pesticides are labeled to tell you how to use them appropriately. I'm going to start with the larvacides. The first two are the BT and the BTI and the BS, which are bacillus, which are both bacterias that we can grow and utilize. The benefits of these two bacteria is they're very host specific and they only kill larvae and typically only fly larvae, which is great because that's what we want. They're non-toxic to humans and animals and all types of other critters. They can be put out in the water sources. Some, like the picture shows here, sorry, I'm going back though, this spray version, that's the way you get the Bacillus sphaericus into the water, but BTI can be put out in a dry form and it breaks down over time, and that's highly recommended. And again, lots of options as to where you can put those. Another one is the spinosad. It's another bacteria, works really well. The downfall here is it is known to kill lots of groups of mosquito, or not mosquitoes, insects. So you do want to probably be a little bit concerned where you're putting it to make sure there's no other insects that'll be heavily impacted. But it's a really good product. It works really well. It is got real low toxicity to mammals and birds, and it actually got the Green Award one year. Smethoprene, which is an insect growth regulator. These are really good products as well. They don't always technically kill the insects. The larva will actually just kind of keep growing and growing and growing and never develop fully. So they just kind of fizzle out because it's designed to work that way. But really good products, no resistance yet determined. But some people don't understand them and can be a little concerned about the usage of them, but these are actually super, super safe. They can be put in many locations. It may be best to not put them by super high expensive fish, as it says that some species of fish can be impacted by them, things like that. But that's, you know, that's the one thing you have to decide is where you're putting it. But for Culex situations, there's no fish in those same spots. So these are really good to use for Culex mosquitoes. And that just shows the different ways you can purchase the products. You can get them as a briquette that breaks down over time, granules, which have to be mixed with water or in a liquid form. So lots of different diversity in the treatment options. How you put them out depends on your product. So some you literally put them out by hand. Some you can use machinery to increase that application. If you're not a licensed person, you do need to use the appropriate application method. The one here on the truck would require a license. The others technically do not. And if you're using just BTI, you don't need to have a pesticide license to do that. Adulticiding is different. To do any adulticiding applications, you do need to have a pesticide license. There's two classes of products still on the market, organophosphate and pyrethroids. The chlorpyrifos or pyrophos is the other way I've heard that is actually being taken off the market, but it's still there for the remainder of this year and maybe next year. I have to double check that one. But the others are pyrethroids. So most of the products we use are pyrethroids, and then malathion is still there. It is highly recommended to rotate at least once every other year if possible, just to prevent resistance. And mosquitoes do become extremely resistant because they have a lot of pressure from other applications, not necessarily directly from vector control, but they can get it from homeowner usage of products as well. With The application, again, it's what's best for your program or for you. There are ways to do with the backpack or the handheld. Those are usually going to be done by structural pest control operators. So people that are working for a pest control company. The aerial application in Texas is only done during emergencies in this kind of aerial. Now, some of our coastal groups do have small planes that they utilize, but that's a big plane that was pulled out for treatment during a disease outbreak. So a lot of our groups, we're talking is going to be ULV application, the cold foggers, which are run from trucks or some type of off-road vehicle. The thermal fogger is also shown here, but most people don't use that one. And just to kind of round it out, we have seen kind of an increase of different groups using this product here. So this is called an intocare trap. It's a little bit of a twist on the design of a trap, because traps are designed for surveillance, really, because you're getting a sample size. You're not getting everybody, you're just getting a few. So we don't consider that a control measure, right? You can't control everybody if you can't get everybody. But these traps were designed to do both. They bring the mosquitoes in. They are designed for Aedes mosquitoes, because she likes the little black container. She wants to go lay her eggs in it. They also have a unique look to them. If you've never seen one, they're not quite a gallon size, but I guess they're close to about a gallon size, and they kind of look like an outdoor speaker. So if you stick it outside, nobody's really going to know what it is. And you always kind of hide it in the bushes anyways, because that's where that mosquito prefers to stay. But there's this little net on the inside. Some of y'all can see that little white net shown in the picture here to the left. That is the part that has the chemicals in it. So the chemicals in this case are an insect growth regulator, which is pyropoxyphene, and a bacterium, which is Bavaria bassiana. So both really safe for the environment and other non-targets. That basically breaks down slowly over time and makes soup, because there's water inside this container. So I call it the soup. It's the soup with all the stuff in it. So she comes in, she gets near that soup, and she lays her eggs in there, and then she leaves. Well, the eggs are going to hatch, and the larvae are going to try to grow, and they're going to try and grow in this soup, and they can't grow because there's chemicals in there to prevent them from growing. But she's going to leave, and she's going to carry that bacteria with her, that Bavaria, and then she's going to take it to other spots. So one thing I didn't mention earlier is that in addition to her liking to bite on multiple people, she likes to lay her eggs in multiple locations, because that's just her way. She doesn't put all her eggs in one spot. And when she does that, she transmits that bacteria. So the concept is she'll take it from here and then take it to natural sites. And eventually she dies. So you can't really see her down here, but this is her legs up in the air. She'll die off, and then she'll have left infected soup behind her. So kind of a neat design. A lot of people that have used it in Texas are really happy with it. It may be a bit pricey up front, but once you've purchased them, you just have to replace the impregnated net that goes on the inside. These do require constant maintenance, which is, I think, only once every 30 days. So it's not terrible. But if you don't continually replenish that water, it eventually becomes regular water, and then you start breeding mosquitoes, and you don't want that. You got to make sure it kills them. And the last thing I'll mention is there is the potential for genetic modifications to come forward. We do have groups. We now have them in Florida. They're testing them, and they're supposed to test them in Houston, Harris County, maybe next year now. I know it got delayed because of COVID, but there's different ways that we can do this, and there's benefits to this. The one most common is the Wolbachia, which is listed here second. This is taking, again, a bacteria that's found naturally in insects and helps regulate populations of insects, but Aedes aegypti doesn't have it for some reason. So what they're doing is they're giving it to the Aedes aegypti, and then they share it with each other, and that leads to offspring death. And then it continues to share through the populations. Another one is gene drive, which is a bit more complex. It's not quite out there on the markets, but it's the future. And then the Oxitec, which is the sterilization of mosquitoes to, again, decrease the future generations. Similar to what they did with the primary screwworm. If you've ever heard that story, the screwworm attacks live animals and can infest them with larvae that will kill them. And they used the sterility technique to get rid of them, but it was a radiation program. So this one's a bit different. So with that, I stayed on time. I wanted to make sure I didn't go over my time, but I do want to thank you all for being here today. This is my email. You can always reach out to me directly, slswiger@ag.tamu.edu. I do have a website. It's Livestock Vet Ento, and we do keep some mosquito stuff up there too, but we have a lot of other insects up there. And in addition to doing CEU classes, we also have a class, which we've been doing for the last couple of years. We did have to postpone last year's, but we are planning to do our classes again this fall. These are run through our Centers of Excellence, Western Gulf Center of Excellence, which is a CDC funded Center of Excellence that's housed here in Texas. So if you are interested in learning more about vectors and mosquitoes and how to maintain them, this is a 3-day class where we get hands-on with all of the stuff I just presented to you. So most people who have attended it have been pretty happy with it. And we have one in Houston, Dallas, San Antonio, and El Paso planned. Now, just pulling up the chat. So yes.
This is Kevin Gibbs. It was really good. You have one question in the chat.
Okay.
Want me to read it to you, or you got able to get
I
it?
have it up. Mention Chagas disease. I know of Chagas in South America. Where is it occurring in Central and North America? So Chagas disease is most prominent in Central and South America. There's actually a lot of cases in Central America, but it also is found in North America. And right now, we have 2 doctors on campus, the Hamers, as we refer to them. They're man and wife. One's an entomologist and one's a veterinarian, and they work very closely with Chagas disease and kissing bugs in the state of Texas. Their most recent data has found that 75% of all kissing bugs so far collected in Texas are positive for Chagas disease. So it's here. It's been here forever. It's just that there's a lot of variations that they're finding out in the biology of our kissing bugs compared to the biology of the kissing bugs in Central and South America that prevent that transmission as frequently. Because we get about, I think right now they average roughly 30 cases of state contracted Chagas disease. But that's, again, that's a low number, right? They're getting like 300,000 in Central and South America. So we have very low numbers, but it is here. The group that's really being heavily impacted by Chagas are dogs. And that's actually what sparked it. That's why Dr. Hamer, the veterinarian, is kind of interested, is that they have a lot of dogs in the state that get Chagas, and they think they're getting it from consuming the bugs, not from the bugs giving it to them. Because if I'm sure some of you probably don't realize, and I should mention this, but the kissing bug itself doesn't pass the disease to you by feeding. It's actually through its feces. So it has to defecate on you, and then you have to scratch it into your body. So it's a bit more complex transmission cycle, which is good to keep it low numbers, but not good for dogs. So
that's new for me because
Dr. Swiger, can you share that flyer that's up on the screen with me? Will you email it to me?
yes. We just got it made like 2 days ago, so I hadn't yet sent it out. So you guys are the first to see it. So I would definitely share it with you, Kevin.
That way I can share it with all of my local municipalities.
I would love that. Thank you.
All right, and I think you have another question that just popped up from Fred Pena.
Yes. All right. So eliminating water pools, that's tough. What else can be done to landscapes and plantings to reduce mosquito populations? The key thing is really having proper drainage. We're never going to get rid of all the mosquitoes, and that's fine. I mean, they're part of the ecosystem. They do play a role, even though we don't want to accept that sometimes, but it's proper drainage. The faster water drains and disappears, the less able it is to support mosquito development. The larvae have to have at least a week's worth of water or they don't survive. So things that you can do to change that, to keep the water from going away. There's not a lot of research to really support that plants repel mosquitoes or prevent them from coming in. Now they may keep them away for a little bit, but they're still going to utilize a water source that's under a citronella plant because they're not going to care. It's water if that's where they want to put their eggs. And then other ways in landscapes, really, and a lot of times ends up being just human error that we leave stuff out. But French drains are not designed to properly remove all the water. So if you've ever looked at one of those before they're put in the ground, they're not designed to keep the mosquitoes out, which is really sad. because they're supposed to be doing a benefit for you, but they're actually keeping mosquitoes in there. But it's just sometimes you just kind of got to look at it and think outside the box and see what your issue is. Like, oh, we're holding water here. We obviously need to adjust this in some way.
Okay, do we have any other questions before we let?
Ask her
Dr.
about
Swiger
the rings, because
The
I use,
dunks?
yeah,
Oh.
I use the dumps a lot. I think they're very effective.
The questions about the effectiveness of the mosquito dunks.
Yeah, the mosquito dunks are highly recommended. The one downfall from them is that they float. So sometimes they can all kind of congregate in one area if you have a really big body of water, and that could be problematic. But they're really beneficial because they're bacteria. They don't affect the fish. They don't affect any animals that are drinking out of that water, and it slow releases the particles into the water. And when the mosquitoes feed on it, it kills them from the inside out. So those are really good products. Plus, anybody can use a mosquito dunk. You can go buy it at Walmart, any store, and toss it into your locations per reading the label, because there are some recommendations on how many to put in a certain site. A lot of our guys that have the pesticide license in category 12 can also buy more advanced, in a sense, like the briquettes, which actually sink. And the benefits of that is they fall down in the bottom of the water, and then they do the same thing, but they can't float and congregate.
Very good presentation, Dr. Swiger. Thank you so much for teaching us about this today. I learned a lot myself, so.
All right. Well, thank you. I appreciate that.
Here's another chat. It says, thank you, Dr. Swiger.
Thank you.
All right. Well, I hope you have a wonderful weekend. We want to thank you for sharing with us today. And I certainly will share that information about the vector workshop with all the municipalities and the folks that I know. So.
Great. Thank you. I really appreciate that.
Thank you. You have a great weekend.
Thank you. You too.